Oh, and there's a couple other things they share with you. They share with you that from the top of the pyramid, if you were standing dead center in the middle of the floor, if you looked straight up, they call that the actual height of the pyramid. That's the distance from the floor to the tip. And there's another type of height that they drew on the side here, and hopefully you guys can see that. That is the slant height. And I wish I could draw this better or demonstrate it better. They use a couple variables depending upon what you need. They use H is the height, and that's floor to tip, like center of the room, looking straight up. And they use L for what is called slant height. And the best way I can think of to remember this one is it's the triangle's height from top to bottom. Because if you notice, these triangles, in order for them to form a pyramid, they're leaning like this. So if I were to pull one of those triangles off and lay it down right here, so for sake of argument, this is a lateral side, or a lateral face, from here to here would be the slant height. And you're going to need that. Okay. You're going to need to have the knowledge of which one's which. Example 1, architecture. The pyramid in California State University, Long Beach has a height of 192 feet. That means if I stand in the middle of the thing and I stare straight up, assuming I could do such a thing, the distance from my feet to the tip of the pyramid inside is 192 feet. Okay, that's fine. That's cool. The base of the pyramid is a square with a side length of 345. It's kind of a cool looking building if you look at it. What is the slant height of the pyramid to the nearest foot? Okay, this is really, really cool. I'm going to flip over, sorry. I'm going to flip over for a minute. So we know that the floor of the thing is a square that is 345 by 345, right? And we also know that the interior height from the tip to the floor center is 192. Okay? They want to know what the slant height is. Now, you might look at this and say, that is impossible to figure out. Well, lucky for us, it's not. If you look at the tip to center height of 192, and you draw a line, again, from that center to the edge of the pyramid, and then you envision the slant height that would be here, you can use the Pythagorean theorem to solve for the slant height, because the slant height would be that red line from the tip of the pyramid sliding down the face of the lateral side to the end. So how do we do that? Well, let's call the height A. You're going to need calculators, but we're almost to the end of the year. You know you need those. Get them out. A squared. Let's call this leg B. Half of 345, the book thankfully solves that for us, is 172 5/10. The sum of those two items squared will give us the hypotenuse, which is the lateral face's slant length, the tilted triangle. The length from the tip of it slide down to the bottom. The sum of those two items is 66,000 620. And that equals c squared. Well, I don't want to know what c squared is. I want to know what c is. Okay, again, I'm solving it as if it's the Pythagorean theorem. C, the square root of 66,000, is 258.1. That, my friends, is the lateral height. They're calling it L. That's this number right here, the red. Okay? That's this number. Back when I was your age, they had a Rubik's Cube that was a pyramid. And if I still had the thing, I would be able to better represent these things, but I haven't seen one of those in a long, long time.
Sixth grade.
Well, that's true. So if somebody has a pyramid that's three-dimensional and you want to grab it, ask them and we could point some stuff out. Now that I have this lateral height, okay, from here to here, I can actually find the surface area of this pyramid if I want to. Okay, each of these triangles has a surface area, and there's 4 of those, and the base has a surface area. So, in order to solve this, I could find all the faces, which would be a base of 345 times a height of 258 divided by 2, right? I could do that. And then I could find the area of the square. Good. I could add them together. Okay, you can do that. And they show you, please look on 545, the pyramid that has been broken apart. So it was a pyramid and they opened it up. Okay, you guys can all see that. The surface area formula. You guys learned the surface area formula for cones or for cylinders, and you guys learned the surface area formula for prisms. We're learning now the surface area formula for pyramids. Instead of doing all that work and finding each area and adding them together, there is a handy-dandy formula. The surface area of the pyramid is defined as the area of the base. That's what B represents. Added to, and this is going to look a little crazy, 4 times 1/2 of the side multiplied by the slant. Okay? I'm going to simplify this, so don't stress. Slant height. Notice they actually took that formula.
Anthony Root and then Joe and Jalen Arsenault to the office, please.
They took that formula and they simplified it just a little bit further. And I am going to write that. Do not memorize this other crazy stuff if you're one of those folks that memorizes. I'm not. Base area added to the perimeter of the base, 1/2 of it, multiplied by the slant height. It's in that box. Do you guys all see that in the notebook box? The surface area of a regular pyramid, regular meaning that it's a square base. The surface area of a regular pyramid is the sum of the base's area, right? There's the base's area, added to 1/2 of the product of the base's perimeter, multiplied by the slant height. And as they take their pyramids and they lay them out, so they turn them into little stars. The distance from here to here, best way I can sketch it, is the slant height. The slanted sides height. Okay, the rest of that you can probably see. The sides. Okay, so the area of the base, which you can find easily by multiplying the sides by itself. You can find the perimeter by adding the sides together 4 times. And you can see the slant height if it's labeled, or you can solve for it like we did above using the Pythagorean theorem, assuming they have you solve it. Either way, This is the formula. Okay, page 545, surface area of a pyramid. We're going to practice this a little. Is everybody with me so far? Everybody copy this? Can I slide over, flip, turn the page if it were? Okay, let's do that. Rather than annoy you further with my fantastic art abilities, we're just going to go with the drawing you see. Example 2 says, find the surface area of the regular pyramid. Step 1. Perimeter of base, which you're going to need, and area of the base, which you're going to need. What's the perimeter of that base? Rachel, can you see it? On page 545, the sum of the sides. She's right. I'm going to go ahead and label that right there. It probably wouldn't be rocket science for me to say you all know the area is 100 square centimeters. Am I right? Lee, thank you. Okay, 10 times 10. Now that we have the data we need, and they also have the slant height. Haley, can you see what the slant height is on that triangle? 13. We don't have the actual height, so if you're standing in the center looking up, we don't have that data. But we do have the slant height of the triangle. Find the surface area. Surface area is defined as the area of the base added to 1/2 of the perimeter of the base multiplied by the slant height. Perimeter is, or area of the base is 100. Perimeter, you guys told me, is 40. And the slant height is 13. You can type all that into your calculator, whatever you want to do. 360. 100 plus 20 times 13. 1/2 of 40 is 20. Altogether, it's 360 centimeters squared. If you worked that in your calculator and didn't get that, is there anybody who worked it and did not get 360? Awesome. So you're working it and it's working out. That's good. All right. You guys want to do another example?
Sure.
I would love to do another example. Unfortunately, that means well, you know what, I'm just going to show you the book and cover the answer because I'm not drawing it. Ethan would shoot himself. It's pretty brutal. My ability to draw stinks. Here you go. I'm going to get this covered. Because obviously if you see the answer and then just quit, you haven't learned anything. Ain't that fun? Hang on, I know you're like, come on, Mrs. Myers, hurry up. Okay. Step 1. Find the perimeter and the area of the base. What's the perimeter, Kat? Sum of the sides, Kat. Go ahead, honey.
Is it 25 times 4?
Yes, ma'am. Yep. Side plus side plus side plus side. Good job. Perimeter is 100. Area of the base is going to be 25 times 25, which is something like
625.
625. Okay? Now that we've solved that, plug it into the formula. Start trying it. The formula is surface area is the base area added to 1/2 of the perimeter times the slant height. What's the slant height of this thing?
42.
42. It's right there. It's the tip to the base. If you were sitting up here, you'd slide down. So 100 times 1/2 times, ran out of space, 42. Okay? Surface area. Formula's there for you. Plug in your answers. Surface area is the area of the base added to 1/2 of the perimeter of the base multiplied by the slant height. You could easily do all of that. What'd you get, Ethan?
2,725.
Winner, winner, chicken dinner. Good job. If you follow the steps, you cannot be unsuccessful. Just follow what they're giving you. Follow the steps. Last thing we're going to do today is the cone. The cone. Surface area of a cone. Picture an ice cream cone. I really don't care what you picture, as long as you are aware of what the surface area of a cone is. Notice they took a cone for you and they kind of stretched it out. They flopped that flat where the ice cream would go piece out. We're including that in our surface area. The spot where the ice cream would go, just put a flat spot there, a circle. Okay? The portion around the pointy cone, so this is a sugar cone we're talking about, is solved a little bit differently. Together, the surface area of a cone is as follows. Pi times the radius squared for the circle portion, so that would be the circle's area. Added to, and this is the flat cone portion where you hold before all the ice cream leaks all over you, is pi times the radius multiplied by the slant height. Okay? Pi times radius times slant height. Okay? All of those terminologies are in there for you if you need to refer back. So, area of a cone, they've got a cone on its slot side. That doesn't change anything. This is example 3. Work it with me. Example 3, they want the surface area of this cone. So first, let's do the circle. Pi times the radius squared. What is the radius, Dylan? We're on page 546. What's the radius of that one that's tilted on its side? Yep. What's the radius of that circle? He's right. So pi times 7 squared is 49, would look something like that. Okay? Added to pi, multiplied by the radius, multiplied by the slant height, which is going to be the tip to the edge of the circle, which they've defined as 24, am I right? Now, they don't, the way they're simplifying it there by having 217 pi, you're going to work it anyway. So let's plug in 3.14 times 49. What do you get, Ethan? Yeah, for the first piece. 150?
154.
Got it. What's 7 times 24? Multiply that by pi.
528.
528? What's the sum of those two items? 682. Notice they came up with 681.7. Same thing. The surface area is about 682 square inches. Okay, that's example 3. Do checkpoints 1 and 2, please.